Welcome back to my channel. Here is an example on linear programming. A tailor has the following material available: 36 square meters of cotton, 31 square meters of zinc, and 35 square meters of wool. He can make out two products from these three materials, namely dress and suit. A dress requires the following: 10 square meters of cotton, 11 square meters of zinc, and 8 square meters of wool. A suit requires 14 square meters of cotton, 14 square meters of zinc, and 19 square meters of wool. If the gross profit realized from a dress and suit is 230 naira and 250 naira respectively, formulate the above as a linear programming model. So we have to formulate this question as a linear programming. We want to translate it to mathematical description. So in this case, the board cannot contain the solution of this, so I have to rub it off. So I have the question here. You can make a screenshot of this question. We want to formulate the linear programming problem. Remember that a tailor can make three material of three, which is cotton, wool, and zinc. He made what? He made two material, which is dress and suit. First thing, if we want to formulate our linear programming problem, is to write down the decision variable. So if you know what are the product of the material that he made? Two. So that is, we have dress and suit. We represent our dress and suit on variable, writing it as a decision variable. That is, we can say that let dress be x1, let suit be x2, because we want to interpret it to what? Mathematical description. So in this case, we are going to have the variable. This is the solution. Let x1 and x2 be the two types of product. So since we have written down our variable, our next step in formulation of linear programming problem is to what? Formulate the objective function. So we have to formulate the objective function, which is to be maximize or minimize. Remember when I told you about maximization? Maximization deals with profit, where minimization deals with cost. If you look at the question very well, we are given that if the gross profit, so it means we have to what? We have to maximize the profit. So our objective function, we can have objective function. Let x1 be the profit on dress and let x2 be the profit on suit. That is, profit on x1 unit of product should be 230. We are being given the profit. Profit from a dress and a suit is 230 and 250 respectively. That is, our dress is having 230 and our suit is what? 250 naira. So profit on x1 unit of the product. Profit on x1 unit of the product is which is dress is 230 naira. You have been given it as a question, and profit on x2 unit of the product of suit or suit product is 250 naira. So this is our profit. If the gross profit realized 230 naira on dress and what? 250 naira on what? On suit. So since we have profit, and whenever we have profit, we have to what? We have to maximize. So total profit for this will not be. What is the total profit for this? Total profit 230 plus what? 250. Remember that on x1 unit, so we have to add x1 unit to this. We have 230 x1. On this, we are going to have what? 250 x2. 250 x2. So the total profit of this will be 230 naira. That is dress plus suit. Our total profit on dress is what? 230. Our profit on what? On suit is what? 250. If you add it together, we are going to have 230 plus S1, 250 S2. So this is the total profit on dress, 230 X1 plus 250 S2. Since we have what? We have formulated the objective function. The step 3 of linear programming problem is what? To write down what? To formulate the constraint. What is a constraint? A constraint is a set of a subject of linear inequalities or equality. So how can we now formulate this constraint? We are being given some parameters that out of that three material, which is cool, which is zinc, wool, and which is zinc, wool, and cotton. That is cotton, zinc, and wool. A made two material. So a dress require the following. So a made two, a made we are not giving that he made what? He made out of three out of the three material. He made two products from that three material. So our dress is a product one, then our suit is our product two, that is dress and suit. If you look this question, on dress we have a dress require the following: 10 square meter of cotton, 10 square meters of cotton. Then we have what? Zinc, 11 meter 11 square meter of zinc. Then we have what? 8 square meters of 8 square meters of wool. On suit, what do we have? On suit, we have 14 square meters of cotton, then 11 square meters of zinc. 11 square meters of zinc is 14, then 11 square meters of wool. 11 square meters of wool. So we have 19 square meters of wool, not 11, 19 square meters of wool, 19 square meters of wool. So this is our what? This is our constraint. So what is our constraint? Remember that we are dealing with profit, and if we have maximized profit here, 230 x1 plus 250 x2. We have maximized profit here, total profit. So, and I told you that whenever we are dealing with maximization of profit, our constraint, we have to add this one to this, we have to add this one to this, we have to add this one to this. So what is this one is 10. So we are going to add 10 plus 41. Remember that our address is what? X1 unit. It can be 10x1 plus 14s2, 11x1 plus 14s2, 8x1 plus 19s2. So in this case, this is 10x1 plus 14s2 is less than or equal to. We have been given the parameter that it tells us the following material. So our square meters of cotton will now be less than or equal to 36. Our square meters of 11x1 plus 14 is equal to what? Is less than or equal to what? 36, 31. Then our square meters of wool, 8 plus 8x1 plus 19x2 is less than or equal to what? 35. So this is how we are going to formulate the constraint. So this is objective function. So since our total profit is this, so we now have maximization of z, maximization z. In objective function we maximize 230 x1 plus 250 x2. So the constraint, our constraint will now be on a dress we have 10. On a dress we have 10 x1 plus I've done it before. So we have to check what the suit. On the suit, what do we have? We have 14 cotton, 14 x2. Remember that we are maximization. Our inequality sign will be less than or equal to the material we have been given before. That the material that have the following available. The material that are available before, which is what? 36 for what? For cotton. So this is what? This is a dress on cotton. This is a what? This is dress. This is suit. So under dress, this is cotton. Under suit, this is cotton. Less than or equal to what? The total available of the what? Of the square meters of cotton. So we have done an 11 square meters of zinc. So we have 11 square meters of zinc. 11 x1 on dress Then what is the unit we have on what? On zinc. We have 11 square meters of zinc. So what is the material, what is the product we have on zinc on soot? So we have 14 S2. So it's less than, is less than what? Is less than 31. Is less than 31. So our last constraint, our last constraint is what? We have 8 square meters of wood. 8 square meters of wood. That is on dress. This is a dress. This is for dress. This is for suit. So this is what? Wool. This is cotton, zinc, wool for dress. Cotton, zinc, wool for what? Cotton, zinc, wool for what? For suit. So last one, what do we have? We have 19 square meters of wool. 19 square meters of wool is less than or equal to what? Is less than or equal to what? Is equal to 35. So these are our constraints for this. And since we are putting the constraint, our last step is what? To add the non-negativity. How can we add the non-negativity? Add the non-negative. Add the non-negative. So if you remember our non-negative, it means what? Our value is what? Our value is what? Our value is not negative. It means since this one is not what? Is not what? Is not less than what? It's not less than 0. The value is not less than 0. It means we are going to have x1, x2 is greater than 0, because this value of x1 and x2 is greater than or equal to 0. So mathematically we now have maximization of z. Mathematically we now have maximization of z, which is what? 230x1 plus 250s2, subject to the constraint 10x1 plus 14s2 is less than 36. 11x1 plus 14s2 plus 14s2 is less than 31. Then 8x1 plus 19s2 is less than or equal to 35. So we are at the non-negativity constraint. x1, s2 is greater than or equal to 0, because of this value of x1 and s2 is greater than 0. 10 is greater than 0, greater than or equal to 0. So 10 is greater than 0. All these constraints, there's no negativity there. So that we have x1, s2 is greater than 0. This is how to formulate the question of the linear programming problem. Don't forget to subscribe to my channel, so whenever I drop a new video on any question, you'll be notified.